Good evening, everyone. Welcome to tonight's living room. Thank you all for coming, everyone in the room, and welcome those of you who might be joining us online. We're so happy to have you here tonight. We are excited about the topic tonight. This always tends to be one of the most heavily viewed online, both live and post-live, as everybody's anxious and excited to learn about some of the data and the information coming out of ASCO, which I believe most of you know is the American Society of Clinical Oncology. So it's a huge oncology conference held at the end of May, beginning of June every year. So we're very, very happy to be able to bring you Dr. Hussain tonight from University of California, San Diego, and our very own Dr. Amy Moore, to talk about what are some of the exciting things that are coming down the pike and that you guys can expect, you know, to be seeing here in the very near future. So we are going to move into the presentation, but first I'm going to ask Dr. Hussain and Dr. Moore to introduce themselves, because I could do it, but historically I always feel like I'm reading some bio off a piece of paper, right? And it comes across much more personal if I let you just do it yourself.
Yeah. No, well, thank you. And so firstly, thank you for the honor of being here. It's really an amazing opportunity to see so many patients all together in one spot, all kind of reflecting and being very candid and frank about, you know, their experiences. And it's helpful for us to actually become a better doctor as well. So my name is Hatem Hussain. I work at the University of California, San Diego, and I've been over there for about 6 years. Prior to that, I was at Johns Hopkins Hospital. And
that's okay place, yeah.
Both, yeah.
Yeah, I learned a lot. And some of my areas of interest right now are specifically actually the EGFR mutation, as well as better understanding how we can increase the immune system's ability to respond. And that may involve figuring out how to effectively combine different agents with the immune system agents as well. So with that, actually, I'll pass it on to Amy.
Well, hey again, everybody. So I am Dr. Amy Moore. I'm the Director of Science and Research here at ALCF, and everybody picks up on my drawl. So I did just move here from Georgia about a month ago. My family came to the Bay Area for my husband's career with a vaccine startup that he launched from his faculty position back at Emory University in Atlanta. But it's a thrill for me to be part of this organization. By way of background, my PhD is in microbiology and immunology, so I actually trained as a virologist, worked with viruses, but then transitioned into cancer research as a postdoc at Vanderbilt University. But then about 10 years ago, I joined a statewide initiative in Georgia that was launched by a former governor that sought to leverage some of our tobacco settlement dollars that the states received by suing the tobacco industry for the harm that they inflicted on the public. And you know, along with Hamilton Jordan, who had been Jimmy Carter's chief of staff, they said, we really need to take this opportunity to move the cancer needle here in Georgia. We need to improve outcomes for our patients. At the time, we were one of the largest states not to have an NCI-designated cancer center. We had high rates of disparities, particularly in the more southern rural parts of the state. So, you know, we launched an effort that, first of all, helped recruit leading cancer scientists across our academic institutions. We know through alchemy the importance of having access to patient specimens. So we launched a biorepository initiative and then had some smaller seed grant initiatives that were funded by taxpayers but sought to give seed grants to particularly young investigators to give them the pilot data they needed to be competitive for larger federal funding. And so it's good for me to be here and to get back to my cancer roots, but also to be so closely connected to all of you, the patients. And you know, the work that we do is really in service of all of you. So that is what drives everything. I mean, that's what we were founded for, is patient-focused, patient-centered. And so, you know, it's a thrill for me to be here with Hatem. He, I think, did all the heavy lifting on this presentation. So together, we're going to try to highlight a few of those advances that were discussed at this year's meeting, and hope that it'll be beneficial for all of you. So without further delay, I want to turn the floor over to Hatem, and we'll try to tag team this discussion.
Sure. And I think I'm actually going to take the liberty to actually sit, because I think it's a little bit more informal to actually do that. So today, actually, we're going to speak about some of the major messages that were portrayed in this large meeting, and Bonnie has kind of referenced actually how large it is. It's actually one of the focal points of each year for oncologists, because that's where a lot of the new data comes out. And this year, actually, there was significant amount of data that was presented about how the immune system can be important in lung cancer, as well as further definition of new data about some of the genes that are responsible for causing lung cancer. So what we're going to do is we're going to dissect out some of these two focal areas and then bring up the highlights and main points. So those main points, actually, I've kind of focused around four major areas. And the first areas are those points that directly involve impacting the management of non-small cell lung cancer. And again, that's the large common denominator for which many different subtypes exist. We're going to speak about advances in small cell lung cancer, which was historically one of the more common cancers, but because of decreases in smoking patterns, actually has now become more rare. And then reference also mesothelioma, because there was some references to new advances in that parallel what we have done in lung cancer. We're going to speak about some of the advances in the gene-based therapies, and that has really truly been revolutionary. And we've heard many stories about how new drugs for the gene-based diagnoses can be important. And lastly, we're going to hint on a point that was raised earlier about early detection and how actually it doesn't have to be an incidental finding, but maybe one day actually there will be the capacity to kind of really effectively develop a strategy that can really reach out to patients. So by matter of reference, it's really important that we all understand that lung cancer is not just one disease. And we now actually better characterize lung cancer through a microscope, histology. And the most common denominator is called non-small cell lung cancer. And even that actually has been further fractionated out into different histologies. Adenocarcinoma is a large component and actually the largest denominator within non-small cell lung cancer, and then squamous cancer. In both of these divisions, there have been big advances. Some of the earlier advances prior to this year have been how do we fractionate out and understand that even adenocarcinoma is not just one disease. We now know that squamous is not just one disease. In fact, actually, some of the recent work has actually even shown that EGFR mutated one disease is not one disease. And actually, Dr. Colin Blakely has kind of done a large work with Trevor Bavona, really kind of understanding some of the fact actually that even a mutationally homogeneous cancer can have many underpinnings that define out why one patient who has an EGFR mutation may do differently than another patient who does. So with that in mind, in this context of how diverse the cancers are, some of the things that were sobering to me seeing this meeting were the fact actually that there were very clear common elements. And some of those elements actually revolved around the fact that immune-based therapy has really moved into each of those subgroups. And we, I want to take pause and note that some of the oncogene-related cancers, the checkpoint inhibitors or immunotherapies still actually have a long ways to go in terms of our understanding about how to integrate those into those types of targeted approaches. But for the vast majority of patients, this meeting brought to light the fact that checkpoint inhibitors, called PD-1 inhibitors, could be integrated into the frontline management of cancer, even preceding chemo, and actually outperforming chemo. And specifically, actually, some of the background behind it was based on tumors actually that express high levels of a marker called PD-L1. And if those levels actually exceeded 50%, one may just need immune therapy and be able to spare or forego chemo for that frontline period. And so that's why I think it's very important after this meeting that we all know what PD-L1 level was diagnosed in a tumor. That's called a tumor proportion score, TPS score, and that's a percentage. And so understanding whether or not that's greater than 50%, between 1 and 49%, or less than 1%, I think is important because it helps to define out the therapy. And
Is it, so one of the things I kind of want to get your opinion on, obviously, and then have people really kind of pay attention to is the sort of the food for thought is that regardless of what type of lung cancer, what type of adeno, whether you have a target or not, that immunotherapy is in the future of a lung cancer patient, regardless of those things. Is that?
So I think it's true. I mean, I think there are certain small percentages of patients who we still need further clarity about how to integrate it. But I think for the vast majority of patients, it's going to be a player.
Right.
And it's going to be a player across, as I mentioned, histology, the adeno, the squame, but also there was a press release recently submitted actually about small cell lung cancer. Now actually kind of potentially having good data in the front line in combination with chemo. So I think this strategy of chemo plus immuno is probably here to stay. And I think we better need to understand as a field, what are the right chemo agents? What is the right dose for chemo? Because the traditional doses may be too high, causing toxicity and even kind of dampening an immune response to what it could potentially be. So along those lines, actually, I have a slide over here that just talks a little bit about how the immune system is actually interplaying. And there are really two key components to having an immune response against the cancer. So one actually is the fact that the cancer has to display itself with things that the immune system can recognize. And we call those neoantigens. And those neoantigens are processed through machinery that gets driven through in the cell, similar to how an EGFR mutation kind of causes a signaling pathway. There are certain pathways within the cell that change the expression on the surface of the cancer to make them visible and allow the immune system to get home to them. Historically, through time, the cancer cells have developed ways of putting on cloaks or brakes to prevent the immune system from attacking. And those are called checkpoints. And specifically, actually, the immune system has negative checkpoints that keep the immune system down so that we don't overshoot. So the way that that has interplayed is by regulating the T cells, by affecting their PD-L1 capacity to bind through an antibody or a set of antibodies. That's how the immune system drugs are working. Okay, so I just want to highlight actually also, and just kind of, I've mentioned this, but just to highlight the fact that this concept of chemo and IO is even going broader than just non-small cell lung cancer. I mentioned small cell, and there will be data presented at the end of this year, likely kind of further elucidating how chemo primes with the immune system. But then even broader out than lung cancer is that the strategy seems to be applicable in mesothelioma as well. So next, actually, I'm going to switch gears. So I spoke a lot about the immune system, some of the relevant kind of strategies that are being vetted, and some of the data that's coming out on that. Now we're going to kind of look at targeted therapies. So many of you actually have been affected by the EGFR mutation, or the EGFR mutant form of lung cancer. And there's been really great advances with new drug development in that space to target the resistance that could even happen after erlotinib, gefitinib, or afatinib, with the new drug osimertinib. And some of the big things at ASCO as well were better trying to flesh out what are some of the mechanisms of why osimertinib may stop at the point that it does stop. And so we have a little bit more clarity on some of these things. We're still waiting on more data. There can be other genes that come up. And so the ways that clinical trials are trying to approach that are by combining different agents. Osimertinib plus a drug that targets MET, other types of events like this. Like with Tarceva and gefitinib and afatinib, there was a new mutation within EGFR. There may be other mutations in EGFR that we have to know about after osimertinib, and we're still trying to understand those. But those do not seem to be a major component right now compared to the bypass pathways. So on the heels of this, our knowledge of EGFR has really kind of set the stage. You know, what the lessons that we learned from EGFR were ones actually that now we're taking beyond EGFR in the setting of ALK, ROS. But also there was some new compounds for different genomic aberrations, specifically fusions. So I'm going to highlight kind of the fact actually that some of the lessons of EGFR are coming outside to other genes, and RET fusions were ones that were really spoken about at this year's ASCO meeting with 2 compounds actually. So the LOXO-292 compound, as well as another compound that was spoken about at a previous meeting called AACR, called the BLU-667 compound. So we're seeing that not only are we getting continued development of these new pill-based drugs, we're getting them for different genes, and they're showing really good benefit. So at this year's ASCO, Jeffrey Oxnard out of Dana-Farber Cancer Institute, you know, really kind of gave some interesting approaches for early detection of lung cancer using cell-free DNA. And there have been many groups actually that have been trying to do this. I've highlighted in this slide a paper that was published in a very high journal from Johns Hopkins, in which on the first upper left panel, you can see that patients who have cancer may have higher detectable DNA to those people who don't have cancer, but not by huge amounts. But when you look at the specific mutations of cancer, and you add in that level of, say, looking for the specific genes, in this specific assay from Johns Hopkins, patients who had lung cancer, breast cancer, colon cancer, those patients could have detectable values compared to patients who did not have cancer. So that meant the test was pretty specific. Furthermore, actually, with stage 4 versus stage 1, there was more detectability with stage 4, which shows the predictable kind of thing that more cells may be releasing more DNA. So what was presented by Jeff Oxnard was the fact that there's been further work to try to tease this out and broaden it so that we're not just looking at mutations in specific genes, but we may be looking at methylation signatures. We may be looking at copy number gain and loss. And when you add in the composite of the mutations, copy number changes, methylation, and at Johns Hopkins they had actually even added protein levels. When you add all of those together, you may be able to increase the sensitivity to find even the smaller cancers. So I do think that, in my humble view, I mean, I do think that at some point, actually, that there will be a strategy about how to use blood tests to better inform even early detection. And maybe that may coincide and parallel and go complementarily with low-dose CT screening and all the rest. And I think the field still needs to tease out how to do that.
Yeah, I think there's a fair amount of debate still about liquid biopsies. And, you know, there's really a continuum of companies that are looking at different points. Like GRAIL is very focused on early detection. Can we detect a cancer before it may even be visible on a scan? Then kind of middle of the road, you might have a company like Natera that's really looking at monitoring a patient response to treatment. And can that either be used to, you know, kind of this watch and wait? We have a patient who's doing well and maybe we can not give them treatment for now, you know, so we can kind of have that conversation. And then you've got groups like Guardant or Foundation Medicine who are using it to help make treatment decisions. So there's a whole continuum of how companies are approaching this, but I think there's still, you know, a healthy amount of debate. There's only one FDA-approved liquid biopsy test currently on the market. There's a lot that are in development, you know, and there are different things that you can look for in the blood. You can look for circulating tumor cells, or you can look for DNA, and those have kind of pluses and minuses depending on what you're trying to do. For example, if you get cells out, then you can look at, from those cells, you can isolate DNA, you can isolate RNA, you can isolate proteins. That gives you kind of more things to look at, and you have the benefit, potentially, of being able to grow those cells in culture and use those for additional studies. If you take the approach of just looking for DNA, you can look for mutations in the kind of work that you're talking about. Some people are looking at the use of RNA, circulating RNA, and that has utility as well. RNA is a little less stable than DNA in the long term. It tends to degrade more easily, so it's kind of harder to work with. But I think, the combination of all those different things, is useful and gives you different information and kind of can be used in a complementary way. But I think, there's a lot of excitement, a lot of work going into liquid biopsies. I don't think we're there. It's not quite ready for, prime time. We're having this discussion, but certainly we're headed that direction.
Yeah, I think, there's been unprecedented movement. And so while we may not be totally there just yet, I do think that with how quickly things are happening in cancer nowadays, that I do think so. And I do think that, as Amy has brought up, is that by having combinatorial assays that are including protein plus DNA plus copy number, the mutations, the methylation, all of this together, you're going to have a very comprehensive analysis. And this is going to be helpful for people who don't know that they may have cancer and early detection, or actually for patients who do have cancer that we want to use for monitoring. Because we now appreciate, by this experience that we've had with EGFR, kind of understanding that cancer can change through time. And so we're going to need better tools to kind of understand how the cancer is changing that are non-invasive and less invasive to do so.